Okay, Chapter 3, Derivatives. Here's another example. And just to review, this formula here is actually a formula for the slope of the secant line. It looks a little different than the formula you may have seen for the slope from intermediate algebra, but it's essentially the same formula, just a different notation. So the secant line hits the curve in two spots, and we want to take the limit as h goes to 0. As h goes to 0, these 2 points get closer and closer together, and in the limit we get the slope of the tangent line. And this, in word problems, that's the instantaneous rate of change. Okay, so here's another function, and so we want to apply this formula to find the derivative. So, and later, a little bit later, we'll get into some shortcut formulas that you can use for computing the derivative. It's good to know to be able to do it from the definition, because the shortcut rule, for one thing, the shortcut rules don't apply to every formula. We have most of the functions we'll be working with have some shortcut rules, but not all of them. So f prime of x is the limit as h goes to 0, f of x plus h minus f of x all over h. So let's plug in apply this formula to our function here. So f of x plus h, replace x by x plus h, so this will be the square root of x plus h plus 3 minus f of x, so it's minus square root of x plus 3 all over h. If we let x equal 0, we're going to get 0 over 0, which is indeterminate. So we need to, what we want to do is multiply top and bottom by the conjugate of the numerator. So the second square root will just change the sign to get the conjugate. So this is the limit h goes to 0, square root x plus h plus 3 minus square root x plus 3 times square root x plus h plus 3 plus square root x plus 3. And it's all over h times square root x plus h plus 3 times plus the square root of x plus 3. Not thinking here. Okay, so on the top, we're going to get quite a bit of cancellation. The outer product and the inner product are going to be the same, except for their sign. We have the square root of x plus h plus 3 times the square root of x plus 3, and for the outer product, and then you have the same thing for the inner product, but with the opposite sign. So really we have to only need to do first times first, and the square roots will cancel, and we'll get I'll write, so square root of x plus h plus 3 times itself, so square root of x plus h plus 3, I'll put that as squared, minus, and then we'll have the last times last, square root of x plus 3 times itself, but and it's a negative times a positive, it'll be negative, so square root x plus 3 squared over h square root of x plus h plus 3. I'll try to write it more carefully this time. X plus 3. Okay. So then the square and the square root will cancel. So we'll have the limit h goes to 0 of x plus h plus 3 minus x plus 3 all over h square root x plus h plus 3 plus square root x plus 3. Okay, so now we can distribute the minus sign. So we'll have the limit h goes to 0, x plus h plus 3 minus x minus 3 all over h square root x plus h plus 3 plus square root x plus 3. Okay, so x minus x will cancel, 3 minus 3 will cancel, and I'll get another piece of paper here. They'll give us okay, so that'll give us the limit h goes to 0 of h over h times the quantity square root of x plus h plus 3 plus square root of x plus 3. And now we can cancel the h's on the top and the bottom. Until we cancel the h's, we have 0 over 0, which is indeterminate, but now we can cancel the h's, and we'll have the limit as h goes to 0 of 1 over square root x plus h plus 3 plus square root x plus 3. And now we take the limit. So as h goes to 0, we just replace h by 0 here. We have 1 over square root x plus 0 plus 3 plus square root of x plus 3. So that's x plus 0 is just x, so 1 over square root of x plus 3 plus square root of x plus 3, and square root of x plus 3 plus itself is just 2 times the square root of x plus 3. Okay, so that's the slope of the tangent line. It's also called the derivative, and it represents the instantaneous rate of change. And that concludes this presentation.